Hi folks, this is Dr. Mughal here. Welcome to another tutorial. And this is a very interesting one. We're going to learn about understanding and creating your own touch screen. I still remember back in 2008, 2009 when the Apple iPhones came on the scene. It revolutionized the electronic industry, primarily because of the touch screen feature of it. People just loved it. And that's what we are going to learn. In this tutorial, you're going to learn many things. So I'm going to actually break it down for you. So the contents would be, we're going to learn about what is a touch screen, what exactly it is, how touch screen works. We are going to create a touch screen using Arduino with a very simple graphical user interface, basically controlling an LED to turn it on and off. We then going to, under that, we are going to go through some of the parts and components that we are going to use. We are using 2.4 inch 240 by 320 resolution TFT LCD display with touch panel LCD compatible with Arduino. It's actually so much compatible that the pins exactly matches with the ones we have for Arduino, and I'm going to show you. I'm going to go through the coding. You might see or might find a lot of tutorials telling you about how to get touch screen connected to Arduino and getting it to work. But you will find very few of them getting the very high accuracy, meaning the touch screen doesn't have the accuracy that you desire. So I'm going to show you some of the tricks that you could do in order to get very high accuracy, meaning the point of touch is actually going to be the exact point of contact where where certain action would take place. We're going to do 3 programs with the graphic test, painting, and creating a simple touch screen. All these 3 codes or sketches, I got it from public forums. I went ahead and made few changes in there and I customized it to my liking. So let's start, and finally we're gonna do a display and demo. But before I begin, I just want to go through some of the theory aspect of it. So what is a touch screen? A touch screen is a display device that allows the user to interact with the computer by using their finger or stylus. Luckily, the controller, the LCD controller we are using, it comes with a stylus also. They can be useful alternative to a mouse or keyboard for navigating a graphical user interface. Touch screens are used on a variety of devices such as computers, laptop displays, smartphone, tablets, cash registers, and information kiosks. We see touchscreen every day. In today's world, even if you go to McDonald's, you can place your order by yourself just using their kiosk, right? So how touchscreen works? What is the phenomena behind it? A touchscreen is a 2-dimensional sensing device made up of 2 sheets of material separated by spacers. There are 4 main touchscreen technologies: resistive, capacitive, surface acoustical wave, and infrared. A basic touchscreen is having a touch sensor, a controller, and a software driver as 3 main components. The touchscreen is needed to be combined with a display and a PC to make a touchscreen system. The sensor generally has an electric current or a signal going through it, and touching the screen causes a change in the signal. This change is used to determine the location of the touch of the screen. In this project, we are using Highlight Go 2.4 inch 240 by 320 resolution TFT LCD display with touch panel LCD for Arduino. A thin film transistor liquid crystal display is a variant of a liquid crystal display that uses thin film transistor technology to improve the image qualities such as addressability and contrast. So what thin film transistor is a very tiny transistor which is composed of semiconductor layers. You're looking in the range of few nanometers with higher quality. Because the LCD controller we are using has a resistive touch screen, so we're gonna totally focus on this part of the technology. Resistive touchscreen is composed of a flexible top layer made of polythene and a rigid bottom layer made of glass separated by insulating dots attached to a touchscreen controller. As you can see in the graphics, the grayish are the pads to make sure there's no contact between the two layers. These screens panels are more affordable these days but offer only 75% of light monitor. And the layer can be damaged by sharp objects. Resistive touchscreen is further divided into 4, 5, 6, 7, and 8 wired resistive touchscreen. So the way I want you to focus on the graphic as I explain this, how touchscreen work. These resistive touchscreen consist of several very thin layers. When someone presses the touch panel, the top layer, the top resistive circuit bends to make the contact with the bottom one, closing a circuit and causing a current loop or a varying signal or voltage. When you press your finger on a resistive screen, the top flexible layer touches the bottom one and the interruption in the electrical current is noted by the device, and it calculates the precise location of the point of the contact. Depending on what button is located under your finger, the software registers the coordinates and performs the command. Resistive touchscreens can generally only be used as a single touch device, but they cost less to make and incorporate into your application and respond to any type of touch. They can be used effectively for simple panel control such as an automotive GPS panel control or other keypad replacement applications. One of the advantages of using these resistive touchscreen is they are inexpensive, they are better resistance to dust and water, can be used with gloves, but however, there are some disadvantages as well. They have a low touch sensitivity, unable to support multi-touch, and poor visibility in sunlight. The touchscreen that you use at local ATM and or the automated supermarket checkout are resistive touchscreens. So let's now talk about the functionality of the touchscreen controller that we have. This touchscreen utilizes resistive touch sensitive input with 4 wires. These 4 wires are connected to Arduino pin, which basically tells the location or the point of contact on the touch screen. So these 4 wires are connected to top resistive coating and bottom resistive coating. In this variant, top resistive coating has electrodes for the horizontal direction, and the bottom resistant coating will have the electrodes for the vertical direction. The top and the bottom resistive coatings measure each other's voltages, and based on that, sensors can determine the location of the touch point. So for example, by powering the pins with 5 volt and ground in the X direction, we can touch the screen, which then connects the top layer with the bottom layer, as can be seen in the graphics, and thus it lets us measure the voltage of this X direction voltage divider through Y pins, which are connected to analog inputs. The same strategy can then be applied to determine Y points. This ultimately gives us a touch point with X and Y coordinates, which tells us the exact point of contact. Let's now discuss liquid crystal displays. What are they? A liquid crystal display is a type of electrically generated image shown on a flat panel display, as you see on our TVs, laptops, or any other electronic gadget. They uses the light modulating properties of these liquid crystals. These crystals do not emit light directly. Instead, they use a backlight to produce images. It's important to know here, these liquid crystals, they actually do not emit light, but they actually use the light in the background to generate colors. I'll tell more details about it, but let's look at, I want you to focus on this configuration on the screen right now. So these LCDs, they consist of an array of liquid crystal segments. And since our LCD has a resolution of 240 by 320, we have a total of 76,800 liquid crystal segments. Now, controlling each segment individually is impossible because of the big number, and they are designed in a 2-dimensional matrix, making an array of 240 rows and 320 columns, and we use control lines to provide them a signal. This way we can control each liquid crystal segment by multiplexing them. Now we can control all liquid segments. And now when we turn the power on row number 2 and column number 2, you see the liquid crystal, the one in the red, lightens up. Okay, so this is how the basic concept of liquid crystal display work. At one time there are thousands and thousands of these liquid crystal displays are going on and off and changing different colors. How they change color? Let's learn about that. Now, and here is an important thing. Since these liquid crystal segments don't emit light themselves, and what we can do is to mix the color R, G, and B to get a desired color. Which means, since now we have to control red, green, and blue values for each row, we now have 720 control lines instead. Three control lines going to each liquid crystal segment, which is basically changing the color of red, green, and blue, and that could be 8-bit, 16-bit, or whatever. Okay, so therefore a total of 140 control lines now. This is important to know when you are trying to understand the code, okay, in Arduino. So this is the basics about the liquid crystal segments. So how a LCD segment would look like under a microscope? Well, here's a zoom in picture of LCD under microscope. Clearly you can see for each liquid crystal segment we have different colors, red, green, and blue. And we change the binary value of these colors to get different shades of green, blue, and red, which then creates a beautiful picture that we see. The more pixels that we got, the more high resolution we have, and the better the picture quality is. So let's get started. So what all you need? Parts and components. Well, I break it down to hardware and software. You need an Arduino Uno R3, and you need a 2.4-inch 240 by 320 TFT LCD display. So you're looking around Arduino being $17, $18, and this LCD controller is going to be like $7, $8. So $25 you can get this project done. And Arduino, obviously, you know, it's an open source, so it's free. You can download it. You can go to these links and purchase these products. In this project, we are using Highlight Go 2.4-inch 240 by 320 resolution TFT LCD display with touch panel LCD for Arduino. This i9341 is actually a 144 color single chip driver for a TFT liquid crystal display with a resolution of 240 by 320. It is comprised of a 720 channel source driver, 172,000 above bytes GRAM for graphic display data of 240 by 320, and it has a power supply circuit. It can support 8, 9, 16, 8-bit data bus or microcontroller user interface. It also has 6, 16, 18-bit data bus of red, green, blue interface, and 3 and 4 line serial peripheral interface. Now moving on to the software part of it, which will be the coding, and this is really tricky. Like I mentioned, there are tons of tutorials and videos that you'll find on YouTube or any other forum, but getting the touchscreen to work perfectly with high accuracy is going to be a huge challenge, and therefore I'm going to tell you a few tricks here. You have to go to these links and you have to download these libraries. If you don't know how to download a library, if you're a beginner, all you have to do is to click on this link right here, and it will actually download the zip file of it, right? So how you add a library to Arduino is all what you need to do is open your Arduino. I'm not going to worry about this part. You go to Sketch, you go to Include Library, and you click Add.zip library. You go here and you look for the, I think I got it to downloads. You click, it's Adafruit GFX, so Adafruit GFX right here. You select your zip folder, you click Open, and it says to me a library named Adafruit Library already exists. So I previously had already added that zip folder to my library, but if you do it, it won't give you this warning right here. Similarly, for some reason, for some reason, I don't know exactly what could be that reason, but this project would work if you have the library function with 1.5.3 version of the Adafruit GFX library. It doesn't work for version that came out after that. Why? If I have to guess or hunch, it would be because they change these libraries, they modify it every now and then, and also these pin configuration of these LCD controllers, they change. Every now they come up with a different product, they change things. I don't know why they do it, but I found it that it works perfectly fine with this function. By default, it's going to get you the latest version. If I go back to my Arduino right here, and I go to Sketch again, and then I go to Include Library, and I go to Manage Libraries right here, it will open up this dialog box. Here you can further filter out, pick display, and you look for Arduino GFX library that you just installed. Okay, I got tons of libraries. So here it is. It's already installed, as you can see, and I have this 1.5.3 version installed. If you actually click on this right here, it will allow you to download different versions. With 1.5.6 being a latest version, I went ahead and downloaded the 1.5.3. The reason it's not showing me over here because currently I have this version installed. Okay, so I told you how to download the libraries. It's an extremely critical part of this project, otherwise you won't be able to get it to work. Now you also have to download 3 more libraries. Here are the links. I will also leave these links in the description as well. And then once you have this part done, we are going to start with our first experiment, which is going to be the Open Arduino, which is going to be the graphic test, sorry. Now, all you need to do here is when you install the libraries in your Arduino, you go to File, you go to Examples, and then you look for TFT LCD screen right here. Yeah, TFT LCD. You go here and you pick graphic test right here. You don't have to make any changes in the code. And yeah, you don't have to make any changes. Oops. Yeah, in this code right here. And what this code is basically, you have the libraries over here. You have the lines, which one is where, basically tell you, and it's all commented out. I didn't change anything. You don't have to change anything, but I did change some stuff for my project. So if you are interested in what I did or what you see on the panel right here, I went ahead and changed that code. So if you need my code, you can go to this link, or you can just go to this examples Arduino file, then go to example, then Adafruit TFT LCD, and then pick graphic test. Okay, all you have to do after that, you have to verify it and then upload it, and that's pretty much it. And once that happens, you should be able to see the graphics on your LCD controller. Okay, so this was experiment number 1. Now moving on to the second experiment, painting. So you will see a toolbar at the top with different colors, and then you are going to pick one of the color using the stylus, and then do the painting. You can write a text, you can draw some graphic on it. Again, my code, which I did little customize it to get it to work at very high accuracy. You can download this link, you can download my file from this link, but I want to show you a few things. So you go to File, Examples, and then you go to SPFD5408 Master, and then you choose TFT Paint. So I'm gonna show you. So I go to File, I choose Examples, then I choose SPFD5408, and then I choose TFT Paint. Okay, Now, there are few things that you need to do here. And what are those things? First of all, I want you to verify it and upload it and see if this is working or not. If this is working, it is great. If it's not working, what you need to do, you need to make sure, I'm gonna put this side by side here. Okay, so you see these LCD control lines, read and write and chip select, they are A3, A2, A1, A0, okay? This should be fine. This thing is critical, okay? If it's not working for you, then I suggest you changing this A1 to A3 and then this changing to 9 and this changing it to 8, okay? Which I also mentioned over here. Important, if you don't get to work as desired, make the following changes in the code, okay? All right. So these are the calibrated values, and I got these values by removing the backslashes here from this part of the code and then going to tools and then choosing the serial monitor. And as you would hover your stylus on top of the surface of the screen, you'll see the numbers changing. And that's how I got those numbers. So I'm just gonna go with these numbers if these values don't work. Moving on to, so this part of the code, these are basically, you know, the human readable colors in the 16-bit code for them, hexadecimal. You have this box size, and this part of the code is we are not using it, but if you need to optimize your values, you can. This is the tricky part of the code. You have to make sure that this is selected as 0x9341 because this is an identifier for the LCD controller. For the Arduino to know what LCD controller we have, we need to set it to 09341. And this is the initial screen, you know, different colors that will appear. This is more about the graphic user interface on the screen that will appear. You can tweak it around if you change, if you need to. If you don't have to, you don't have to. And then also you have, where is that pressure? Yeah, here it is. So here you have these minimum pressure and the maximum pressure. The minimum it's basically a sensitivity of the stylus. You can choose it to 0, I chose it 10, and then max pressure is 1000. Okay, so go ahead and upload. Now once the code is uploaded, it should appear on your screen. As you look at the screen right here, I'm gonna move my stylus right here, and then I have to pick different colors, and then I can do the drawing. So I'll pick red here, or maybe yellow. Notice here my sensitivity is not really good. I'm trying to pick yellow, but it's choosing blue here, and if I make a line, it's not in the right direction. It's actually offset, so it's not really accurate. You know, the accuracy is not really good. If I choose pink, it chooses red. And so how do we fix this? Well, let's look at this. So I want you to go to actually I already have it over here. I want you to go to documents and then Arduino and your libraries, where your libraries are installed. And then because we are using this this library SPFD5408 touchscreen, we go into this library for this one right here. And then we choose this touch screen, which is a C++ file right here. Let's double click on it. And I want you to go to line number, actually edit and go to line number 159. I need to close this. Go to line number 159 and then you click OK. Okay. This is line number 159. What I want you to do is actually remove these backslashes and then save this file again. Now you go back to your Arduino code that you have over here and then upload the code back again. And then let's try if the stylus is working properly or not. Now, here, let's see. Let's pick yellow. Again, it's not working. I'm trying to pick yellow. It's not letting me pick. You know, it's not letting me doing anything. Okay, let's see if we can further fix it. So let's try now. Hey, there you go. Green, sky blue, blue, purple, red. So I'm able to pick. See the accuracy now? It's a lot better now, a lot more accurate. You can actually tweak around with this 103 number right here. If you go back to your Arduino file, right here, I already had it open, so I can double click here. I can tweak around with this number to further improve the accuracy. Right now it's pretty good, pretty decent, but you can tweak around with these numbers. Say you want to go with 1011 and keep on changing and see if where you get the perfect accuracy. So this is experiment number 2 right here. Let's now move on to experiment number 3, which is basically turning the LED on and off. So I go here, I choose file, and I choose open. Again, I would leave the link in the description for all these files, and you can download the code. This time we are doing LED on and off. Yeah, we updated. I select this file, click open, and here is the file. Okay, again, you have to do the same thing. You have to first upload it and see if it's working. If it's working, then it's great. If it's not, you have to do the same thing that you did for the previous experiment. It didn't work for me. The original file didn't work for me, so I had to change it. So A3, A2, A9 and 8, pin number 9 and 8. Okay, these are my calibrated values right here. The minimum pressure and the maximum pressure, the box size right here. I'm basically gonna have 2 boxes, one in blue, one in yellow. That's their location is. So if you look at the top left corner of your screen, that's where the coordinates are 0, 0. And then 120 by 120, that makes a square box. So remember, it's a 240 by 380 resolution LCD controller. I want them to display LED on and LED off in those boxes, and then I have further added some text which is going to be displayed at the bottom of those buttons. And then the coding is pretty simple if you just go through it. Because of the Arduino that we are using, there's only one pin that's available, which is A5. We are going to connect our LED to A5. If you wish to connect it to the resistor, which I would really recommend, I didn't do it, but I really recommend you adding a resistor to your LED, and then it should work. So let's make sure you make all those changes that I mentioned. You have this begin TF. This is the critical part. Make sure you have this connected to 09341, because that is the identifier for the LCD controller we are using. Except for that, you didn't have to change anything. Basically, you look at these pins right here. You calibrate these values right here, and you change the identifier number for your LCD controller, which is 09341 in our case. Rest, you don't have to change anything. Okay. All right. Let's go ahead and upload it and see if it's working or not. Okay guys, with this I'm going to finish this tutorial. I wanted to go in very detail, give you step-by-step instructions on how to do it and how to fix this glitch in this LCD controller. I hope you enjoyed the video. If you haven't already, please subscribe to the channel and keep watching, and I shall see you soon in the next video. Bye.